Hello, my name is Rasmus Jørgensen. I'm going to create this screencast. I'm an agronomist and senior researcher at Aarhus University. At the conference, Søren, Skovsen, who is a computer vision expert, he will present this presentation. What you see here is Robotti, a robot from Agro seeding maize in 75 centimeter rows. And when the crop emerged, it was cleaned between the rows mechanically, which you see here. And then it was sprayed between the rows with a band sprayer, which used 2 nozzles per row and sprayed in 25 centimeter bands. That's what you see with red. And then the enrichment of images collected was used to create maps, weed maps, as you see here. I will come more into that. But we was also able to, because we know where the bands are, to separate into intra-row areas, mapping weeds and crops, and inter-row between. So we will focus on the inter-row weed population for targeted crop protection. So, if you Google inter-row weeding, you get images like this from showing crops and rows, and some is spraying in the rows, some are cleaning mechanically. But common for all is that not really reporting what they're seeing out there. And you need that kind of intelligence in order to be able to plan the next action. For example, here and here, when you're doing mechanical weeding, why not monitor the crop status and the weed population in here? Or when you're spraying, band spraying, why not report what you're seeing between the bands? So the key here is, how is the crop doing? And we have this case study, which you saw where Robotti were seeding, and then it's mechanically weeding 2 times, 20 days after seeding, and 30 days after seeding. And then 36 days after seeding, 1 band spraying were done. And then the farmer, he chose to do field level spraying in one of the fields. I'll come back to that. But the key thing here is the view from the robot, front eye, which you use for remote surveillance. But down here, I zoomed in, you see it here, there is a camera, and that's a CropEye camera we're using either with 4 floodlights or with 2. If you want to cover the whole width, you need 4 of these CropEyes, but here there's only 1, so it's mapping 10% of the traversed area of the camera. That's equal to approximately 3% of the total area, which will be mapped. So, the images uploaded to the cloud and processed is images like this. And what we will look at in the coming is, when this one collects images like this, we will look at the band spraying. So we will have the effect of the 2 mechanical weeding operations. So let's enrich it with the YOLO model, which many other, which is very common to use. And it plays a bounding box, and it classifies here into maize, into thistles, into dicot, the red ones, monocots, and the blue is dicot weeds. And then you have this little one called plant stem emergence zone. It's trying to tell exactly where the crop is emerging. That you can use for example, side shift if you want to control the weeding more accurately. If you look at the image, just count how many weeds and crops do you have. You can, by using interpolation, weighted interpolation, you can get seasonal maps, dicot maps, monocot weed maps, the plant stem emergence zone, and the maize maps. And if you look at the crop, there are areas which are, you can see white is from 0 to 1, and green is 1 to 5, and it's kind of logarithmic. So here you can see there's some areas here where the density is lower, and it's lower than maize, and that's because leaves can enter with higher likelihood than if you just have this little area representing the crop. But let's focus on the wheat. But as I said, we are treating this differently. So we are treating this area different compared to this one. This is cleaned mechanically twice, and then we are band spraying this area. So we also should separate the two if we should, at least that's a claim, make wise decisions how we should do the weed management. So let's zoom in and focus on that. So if you're within that area, you belong here, the center of the bounding box. So this bounding box, even though it's outside here, will belong to the intra-row area. So let's take the field level map and now split it into the intra-row at the band spraying time. And you can see, suddenly we can see more thistles in the intra-row where we are not doing anything. In the mechanical area, it seems like we have removed most except the perimeter. The dicots we can see in the perimeter, there is a lot of weeds. So, and that's on field level, but it seems like it's also in the inter-row area, even though that's where you do the mechanical weeding. We talked with the operator and he said the perimeter problem here is because there was a plow ridge and that prevented the mechanical weeder to reach the inter-row area. That is valuable information because then you could change your way of handling this. For example, by instead of band spraying, you could spray full width. It was not done here because we were not capable of reporting it with this accuracy at the time of the operation. But let's focus on the weed part and agree that you can see here for dicots that between the rows, mechanical weeding has really have an impact compared to within the rows where you at time of spraying have done nothing. So you should separate these two. So let's focus on that now. So we will get rid of the field level, agreeing that don't look at the field level when you do two different modes of action. So here we have the weed count, but what we could also do is look at the coverage. So if you look at the bounding box, we could use the area they cover in the band. And that's what we're doing here, but we're also adding the temporal dimension. So this is the first mechanical weeding for dicot weeds, that's this one. And then the second and the third. And you can see for the inter-row area, here the camera failed. But for the inter-row area, you can see it's getting more and more towards light green or white. So it works, except the perimeter. And if you look at here, it also, that's an intra-row. It seems like it's just growing and growing and growing. And you would expect that. But in this field, it seems like it's not really a high density compared to this one. So, for sure, it's important to have this temporal variation. And you could also now do inspection, say, why is this one where you do mechanical weeding? There's already an effect here, but here I would expect it to disappear. And here, but it's just staying there. So let's do a virtual field walk and look at this area. And what you see is that it seems like the mechanical weeding in this area is not working. In the that's the intra-row area. It's really dense. I'm not happy on behalf of the crop, but here it's also not working. And that's because there is it seems like the wheel controlling the depth here is going up. It's hard, the soil is hard, so it's running over the crop, not doing the cultivation. So now you know there is a troublesome area here, so you could take action if you had that information. If you should make some advice, I would probably say that looking at these maps, I would recommend to do band spraying a lot earlier. That's one thing, if you look at this. But you could also say that you should probably do full width spraying in the perimeter of the fields, both fields, in order to do the weed control. They're compensating for the mechanical weeder cannot do what it's supposed to. So that intel you're getting, and you can make wise decisions. But if you looked at the field level, you could easily, you don't know if you do mechanical weeding or inter-row weeding. So here, separating it definitely is beneficial. If you then look at, did we save any herbicides? And then for sure we did save herbicides. If you look down here where it's only band spray once and the farmer decided that's sufficient, the treatment frequency index is kind of a normalized index of, if it's 1, that's acceptable level. If you go above, then it's kind of saying you're kind of spraying 2 times with recommended doses. So here, because we're only treating 1/3 of the area, 25 centimeters of the 75, you get a really high save. You save 2/3. Then you can transform it into what's that called? It's a load index, pest index. So that's how much load you put on the environment. But what happened here was the farmer, he visited this field at this time and he panicked. So he just sprayed the whole field. But if we looked at it, it's perhaps a wise decision. But if we had flipped the strategy, prioritizing band spraying higher than mechanical weeding, then you would have probably saved a lot, perhaps sprayed twice. So you would still have saved a lot of herbicides in this field. So overall, it's beneficial. So I think the key takeaways in this short period, while we're looking at this, I'm looking at the camera placed behind the implement, just a fisheye camera, not a high quality one. But let's say if we had the camera behind the implement, then we would have had intel the second, or at the time of operation, that could be used for surveying if the implement is doing okay, doing early warnings to the operator or the farmer. But it could also be used for future planning, because when we have the camera like we have here in what I presented, we are always one operation behind. So the key takeaways, dual weed mapping is needed if you have 2 different ways of treating your crop bands and between the bands. High resolution images and deep learning can definitely leverage that. But what is really important is this kind of spatial temporal thing. If you have information before you seed, it would be valuable in your planning. After you seed it, if you place the camera behind the seeder, I have often seen that the seedbed is not as clean as you expect in all areas. So you could use that to decide if you should do pre-emergent spraying in some certain areas. And then, of course, split it. But in the future, when we use the knowledge we build up here, I think the most important is do look back. It's so important that you place your camera system behind the implement, whether you are a tractor or a robot. For a robot, it's also safety because you don't have an operator to survey it. So remember to look back. Place, if you can, the camera behind, and then use the new techniques for machine learning to survey and do the mapping. So while it's working or after treatment, you can utilize the map I have showed in this project. Yes, that was a quarter of an hour. So if you have any questions, please ask them to Søren, because this is a screencast, so you can't ask questions. Yeah, you can add a comment and I will try to reply.